The discovery of the secret moon. For centuries, humans have looked up at the night sky and marveled at the moon, the silent companion that has illuminated our nights and shaped our calendars, our myths, and even our tides. Its familiar face, etched with craters and mountains, has inspired poets and astronomers alike. But now scientists are revealing something extraordinary, something that has been hiding in plain sight. Earth, it turns out, may not have just one moon. A second, much smaller, and far more elusive companion has been discovered, a secret moon that has evaded our gaze for decades. And unlike the moon we all know, this tiny satellite is a fleeting visitor, a cosmic hitchhiker captured temporarily by Earth's gravity. The discovery challenges everything we thought we knew about the space around our planet and opens the door to a new era of observation and understanding. This secret moon is not a vast, glowing presence dominating the night sky. It's a miniature satellite, likely only a few meters across, far too small to be seen without powerful telescopes. It doesn't cast the kind of shadow we associate with lunar eclipses, nor does it reflect sunlight in a way that would make it easily visible to the naked eye. In fact, that's precisely why it remained hidden until now. These mini-moons, as astronomers call them, are fleeting, often captured in Earth's gravitational field for only a few months or years before escaping back into the vastness of space. They are cosmic phantoms whispering across our skies, invisible to all but the most meticulous observers. The detection of this secret moon is a triumph of modern astronomy, combining decades of sky surveys, sophisticated algorithms, and the relentless dedication of scientists determined to map every fragment of matter orbiting our planet. The team responsible for this discovery used a combination of ground-based telescopes and advanced computational models to track the subtle motions of near-Earth objects. By analyzing vast amounts of observational data, they were able to pinpoint anomalies, tiny specks of light, moving in a way that couldn't be explained by known asteroids, satellites, or debris. The object's orbit was consistent with a body temporarily bound to Earth, circling our planet in a delicate gravitational dance. What makes this discovery so fascinating is the precise mechanics of how Earth can capture such an object. Gravity, of course, is the primary force at play, but capturing a mini-moon is far from simple. In the vast expanse of space, objects are constantly moving at tremendous speeds. To become bound to Earth, a celestial object must enter just the right trajectory, approaching with a velocity and angle that allow Earth's gravity to overcome its inertial motion. Too fast, and it simply flies past us, continuing its journey around the Sun. Too slow, and it could collide with our planet or be flung into a different orbit entirely. The secret moon we're observing represents a perfect cosmic alignment, a brief intersection of forces that allowed it to become Earth's temporary companion. Astronomers have long suspected the existence of such mini-moons, but capturing one in real time is exceedingly rare. Earth's gravitational field is not strong enough to permanently retain these small bodies, unlike our main moon, which was likely formed through a cataclysmic collision billions of years ago. Instead, mini-moons are transient, their lifespans measured in months rather than millennia. They enter our orbit, sometimes completing several loops around the planet, and then escape, returning to the Sun's dominion. This makes the observation window extraordinarily small, requiring constant vigilance, precise instrumentation, and rapid data processing. The implications of this discovery extend far beyond simply cataloging another object orbiting Earth. Mini-moons are a window into the population of near-Earth objects that are otherwise difficult to detect. They are remnants of the solar system, ancient rocks drifting silently through space, each carrying a story of cosmic formation, collisions, and the forces that have shaped our planetary neighborhood. By studying their trajectories, composition, and behavior, scientists can gain insights into the distribution of small asteroids, the risks they may pose to Earth, and even the history of the solar system itself. The process of confirming the existence of this secret moon was meticulous. Scientists first noticed unusual motion patterns in a small object cataloged by the Catalina Sky Survey, a project designed to detect near-Earth asteroids. The object's orbit didn't match the expected paths of known asteroids or space debris. It was moving in a way that suggested it was influenced primarily by Earth's gravity rather than the Sun. From there, a series of observations were coordinated across multiple observatories worldwide, each providing additional data points to refine the object's orbital parameters. Computational models simulated its past and future trajectory, confirming that it had indeed been captured by Earth and would eventually escape, likely within a few months. One of the most intriguing aspects of this secret moon is its size. Unlike the Moon, which spans over 3,400 kilometers in diameter, this mini-moon measures only a few meters across, roughly the size of a small car or a modest house. Its tiny size is a double-edged sword. It makes detection incredibly challenging, but it also makes the discovery a remarkable technical achievement. Observing an object this small, moving thousands of kilometers above Earth, at tens of thousands of kilometers per hour, requires instruments capable of detecting minute changes in light, position, and velocity. The fact that astronomers could identify and track such a fleeting companion speaks volumes about the advances in observational technology over the last few decades. The Moon's orbit is highly unusual compared to our familiar lunar companion. While the Moon follows a relatively stable, near-circular path around Earth, mini-moons exhibit chaotic trajectories. They often trace elongated orbits that can tilt relative to Earth's equator, looping in unpredictable paths influenced by the gravitational pull of both Earth and the Sun. The delicate balance that keeps them in orbit is temporary. Any slight perturbation, the gravitational tug of the Moon, a close pass by Earth, or even solar radiation pressure, can alter their course, sending them back into heliocentric orbits around the Sun. In a sense, these mini-moons are cosmic vagabonds, transient travelers caught briefly in Earth's gravitational embrace. Beyond the technical and scientific significance, there's also a philosophical aspect to this discovery. Humanity has always perceived the night sky as vast and empty, punctuated by familiar celestial landmarks like the Moon, planets, and bright stars. The realization that Earth can temporarily capture objects from the depths of space challenges our understanding of the immediate cosmic neighborhood. It suggests that the space around our planet is more dynamic and populated than previously thought, with tiny visitors arriving and departing in a silent dance that unfolds over months and years. The night sky, it seems, is not as constant as we assumed. It is alive with movement, subtle and fleeting, carrying with it secrets of the cosmos waiting to be uncovered. This secret moon also raises questions about the potential for future exploration. Because it orbits relatively close to Earth, it presents a unique opportunity for spacecraft missions. Scientists and engineers have long dreamed of sending probes to near-Earth asteroids to study them, test new technologies, or even practice planetary defense strategies. A mini-moon, by virtue of its proximity and temporary orbit, could serve as an ideal test bed. Missions could be launched at relatively low cost and risk, allowing humanity to examine an extraterrestrial body without venturing far into the solar system. Even more tantalizing is the possibility that such a moon could carry valuable resources, small quantities of rare metals or other materials that could one day support space-based industries or fuel further exploration. Yet, despite the excitement, the discovery also reminds us of the fragility and transience of these cosmic companions. Unlike the Moon, which has been a constant presence for billions of years, mini-moons come and go. They are fleeting visitors whose existence is marked by a brief window of observation. Scientists must act quickly to study them while they are within reach, because once they escape Earth's orbit, they may never return. This ephemeral nature adds urgency to the pursuit of knowledge, pushing astronomers to refine their detection techniques and observation strategies, ensuring that no opportunity to study these hidden travelers is missed. In some ways, the secret moon is a symbol of the universe itself, elusive, dynamic, and full of surprises. It challenges our assumptions, expands our horizons, and invites us to look beyond the familiar. For centuries, humans have taken the moon for granted, assuming that our celestial companion was unique and unchanging. Now, with the discovery of this tiny, temporary satellite, we are reminded that the cosmos is far more intricate and unpredictable than we imagined. Each observation is a chance to learn, each orbit a fleeting lesson in gravitational physics, celestial mechanics, and the nature of our solar system. Astronomers are already planning follow-up studies. The next steps include detailed spectral analysis to determine the object's composition, measurements of its rotation and surface properties, and long-term tracking to refine predictions about its orbit. There is hope that studying this moon could also shed light on the broader population of small, near-Earth objects, revealing how many similar bodies may be captured by Earth's gravity over time, and what role they play in the evolution of our planet's immediate environment. These investigations could ultimately inform everything from planetary defense strategies to future exploration missions, providing a practical and scientific payoff that extends far beyond the thrill of discovery. In essence, the secret moon is a reminder that Earth is not isolated. We live in a neighborhood that is alive with motion, where objects large and small drift, collide, and occasionally pause to join our planetary system for a brief time. It underscores the interconnectedness of the cosmos, the invisible threads of gravity that shape the paths of objects across millions of kilometers. And it invites humanity to embrace a new perspective, one that acknowledges that the universe is not static or simple, but dynamic, ever-changing, and full of surprises waiting to be discovered. The discovery of this hidden moon is a triumph of human curiosity and ingenuity, a testament to our ability to see what others cannot. It combines advanced technology, theoretical models, and tireless observation, revealing a secret world just beyond the moon's familiar glow. For astronomers, this is both a challenge and an opportunity. A challenge to understand the delicate mechanics that allow such a moon to exist, and an opportunity to study a miniature satellite in a way that has never been possible before. It's a reminder that even in the night sky we thought we knew so well, there are still mysteries lurking, waiting for the right moment to be revealed. As this secret moon continues its brief journey around Earth, it serves as a cosmic whisper, reminding us that the universe is far larger, far more complex, and far stranger than our everyday experience suggests. And while it may be small, invisible to the naked eye, and fleeting in its presence, its discovery marks a monumental step forward in our understanding of Earth's place in the cosmos. In the coming months, as astronomers track its path, analyze its properties, and unlock the secrets it carries, we will be reminded that sometimes the most extraordinary companions are the ones we least expect. The tiny visitors that pass through our lives, leaving a lasting impression on science, discovery, and the imagination. The nature and behavior of the secret moon. While the discovery of Earth's secret moon is remarkable in its own right, the second point that captures the imagination and challenges our understanding of the cosmos is the potential origin of these miniature satellites. Unlike our large, stable moon, which likely formed billions of years ago from a catastrophic collision between Earth and a Mars-sized body, mini-moons are temporary visitors, captured from the vast population of near-Earth objects that wander through space. But where exactly do they come from? How do they arrive in Earth's gravitational embrace? And what secrets could their origins reveal about the solar system itself? Astronomers believe that most mini-moons are asteroids, small rocky bodies that travel through the inner solar system. These asteroids are remnants of the early days of planetary formation, leftover fragments from the cosmic construction sites that formed planets, moons, and other celestial bodies. They range in size from tiny rocks measuring a few meters across to much larger objects spanning hundreds of meters. In the vastness of space, these fragments drift along elliptical orbits around the Sun, occasionally crossing paths with planets like Earth. Most pass harmlessly by, but a fortunate few encounter the precise conditions necessary to be captured temporarily by our planet's gravity. The process of capture is deceptively complex. For a near-Earth asteroid to become a mini-moon, it must approach Earth at a precise velocity and trajectory. Too fast, and it simply continues around the Sun unaffected by our planet's gravity. Too slow, and it could collide with Earth, burning up in the atmosphere or striking the surface. The asteroid's approach must be perfectly aligned to allow Earth's gravitational pull to slow it down enough for it to enter orbit, but not so much that it crashes into the planet. This delicate balance explains why mini-moons are so rare and why they have remained hidden until the advent of advanced telescopes and computational models. One of the most fascinating aspects of these captured moons is that they are transient. Unlike our primary moon, which has remained in a stable orbit for billions of years, mini-moons are temporary guests. Their stay may last only a few months, sometimes stretching to a few years before gravitational interactions with Earth, the Sun, or even the Moon itself alter their trajectory, sending them back into heliocentric orbits. This fleeting presence makes studying them both challenging and urgent. Scientists must identify them quickly, track their orbits with precision, and gather as much information as possible before they disappear into the depths of space. The origin of these mini-moons is not merely a question of where they came from, but also what they can tell us about the broader population of near-Earth objects. By studying their composition, size, and trajectories, scientists can infer the characteristics of the population from which they originated. Some mini-moons are likely fragments of larger asteroids broken off by collisions over millions of years. Others could be remnants of comets, icy bodies that have ventured close to the Sun and lost their volatile materials, leaving behind a rocky core. Understanding their origin provides valuable insight into the dynamic processes shaping our solar system, revealing a level of complexity and motion that is invisible when we focus only on planets and moons. The study of mini-moons also has profound implications for planetary defense. While these tiny satellites are harmless due to their small size, their presence demonstrates that Earth is constantly interacting with a population of near-Earth objects, some of which could pose significant risks. By understanding the mechanics of how objects are captured, scientists can refine models that predict the paths of potentially hazardous asteroids. Each mini-moon is essentially a natural laboratory, offering a real-world case study of gravitational interactions, orbital dynamics, and the subtleties of celestial mechanics that govern the inner solar system. Furthermore, the origin of mini-moons raises intriguing possibilities about the delivery of materials to Earth. Some scientists theorize that these small bodies could be remnants of primordial material from the early solar system, carrying clues about the chemical composition and processes that shape the planets. They might contain elements essential to life, organic molecules or isotopes, that help us understand the formation of Earth's atmosphere and oceans. By studying these secret moons up close, whether through telescopes or future robotic missions, humanity could gain unprecedented insight into the building blocks of life and the cosmic history encoded in small asteroids. Observational evidence supports the idea that mini-moons originate from the near-Earth asteroid population. Researchers have simulated the capture process using detailed models of the solar system, tracing the paths of millions of asteroids over time. The simulations reveal that only a tiny fraction of these objects approach Earth with the right conditions to be captured, confirming that mini-moons are both rare and fleeting. Moreover, the simulations suggest that Earth likely captures one mini-moon at any given time, although it may go undetected until modern instruments are capable of observing it. Some of these moons may remain in orbit for just a few weeks, while others could linger for several years before being ejected by gravitational interactions. Another intriguing aspect of mini-moon origins is their potential connection to Earth's moon. Some theories propose that debris from collisions involving the moon or Earth itself could contribute to the population of near-Earth objects. Over billions of years, meteorite impacts may have ejected fragments into space, some of which eventually drift back toward Earth. These fragments, small and rocky, could then be captured temporarily as mini-moons, creating a subtle link between Earth, its primary moon, and the transient companions that occasionally visit our skies. This idea emphasizes the interconnected nature of celestial objects and the constant motion and recycling of material throughout the solar system. The discovery of Earth's secret moon also highlights the role of advanced technology in understanding the origins of such objects. Ground-based telescopes, equipped with sensitive imaging systems, are now capable of detecting objects just a few meters across at vast distances. Combined with sophisticated computational models, astronomers can simulate the gravitational interactions and orbital dynamics that lead to temporary capture. Artificial intelligence and machine learning algorithms are increasingly employed to sift through massive datasets, identifying anomalies and potential mini-moons that would otherwise go unnoticed. These tools not only confirm the existence of these objects, but also help trace their origins, shedding light on the history of our cosmic neighborhood. The origin of mini-moons also carries profound implications for future exploration. Unlike distant asteroids, which require significant energy and resources to reach, mini-moons offer a nearby laboratory for testing spacecraft technologies, mining techniques, and even planetary defense strategies. A small, temporarily captured object could serve as a stepping stone for humanity's efforts to explore and utilize space. By sending robotic probes to study a mini-moon, scientists could test landing techniques, resource extraction methods, and orbital maneuvers that will one day be crucial for missions to asteroids, Mars, and beyond. In this sense, the origins of these moons are not just a matter of scientific curiosity. They could directly shape humanity's future in space. But the origin story doesn't end there. The discovery prompts deeper questions about how common such phenomena are in the solar system. If Earth can capture mini-moons, might other planets do the same? Could Mars, Venus, or even giant planets like Jupiter and Saturn temporarily hold small companions? Understanding Earth's mini-moons provides a model for exploring this possibility elsewhere, offering a comparative framework for studying planetary systems and the dynamics of small bodies throughout the solar system. Each captured object is a piece of a larger puzzle, revealing how gravity, motion, and chance combine to create fleeting companions in planetary orbits. The tiny size and transient nature of mini-moons also emphasize how delicate these systems are. A minor gravitational perturbation, a close pass by the moon, the influence of solar tides, or even radiation pressure from sunlight can destabilize the orbit, sending the moon back into the sun's domain. This instability illustrates the complex interplay of forces governing near-Earth space, highlighting the precision required for capture and the rarity of observation. Each mini-moon, therefore, is a fleeting witness to the subtle cosmic choreography that shapes the environment around our planet. Finally, understanding the origin of Earth's secret moon reminds us of the broader beauty and complexity of the universe. These small, temporary companions challenge our perception of space as static and predictable. They invite us to consider the countless interactions occurring every moment where tiny objects drift into and out of planetary gravitational fields, carrying with them the history of the solar system. By studying their origins, we not only learn about the objects themselves, but also about the intricate gravitational dance that governs celestial mechanics, the unseen population of near-Earth objects, and the dynamic, ever-changing nature of the space around our home planet. The secret moon, tiny and elusive though it may be, is more than just a cosmic curiosity. It is a key to understanding the flow of material through the solar system, the forces that govern near-Earth objects, and the delicate balance that allows such bodies to be captured, studied, and eventually returned to the void. Its existence is a testament to human ingenuity, the advances of modern astronomy, and the relentless pursuit of knowledge that pushes us to uncover what has long been hidden in the skies above. Implications for science, space exploration, and Earth's future. The third and perhaps most fascinating aspect of Earth's secret moon is the potential for scientific discovery and exploration it represents. Unlike our permanent moon, which has been studied extensively over decades and through manned missions, these miniature moons are fleeting, elusive, and filled with untapped possibilities. Their temporary nature, combined with their proximity, makes them unique laboratories for testing everything from space technology to theories about the early solar system. Understanding and studying these secret companions could unlock secrets about our cosmic neighborhood, the origins of life, and the future of humanity in space. To begin with, mini-moons offer unprecedented opportunities to directly study near-Earth objects in ways that were previously impossible. Most asteroids and comets pass Earth at such distances that sending probes or landing on them is costly and complex. The discovery is more than an astronomical curiosity. It is a clarion call to explore, understand, and embrace the dynamic cosmos of which we are a part. For a fleeting few months or years, these small moons grant us access to the mysteries of the solar system. And in that brief time, humanity has the chance to learn, innovate, and prepare for the next great leaps into the stars. The temporary companions circling our planet are proof that Earth's neighborhood is far more complex, dynamic, and full of surprises than we ever imagined. By studying their orbits, origins, and materials, humanity takes another step toward mastering the cosmos, understanding the forces that shape it, and securing our place within it. The secret moon is small, transient, and elusive, yet its discovery opens a universe of opportunity, scientific, technological, and philosophical, that will echo through decades of exploration and discovery.